Suppose we have the following structure: CH3, CO, OH. This is the acetic acid. So we draw Lewis structure, and they asked us to find the geometry. If we look to this structure, we have 3 central atoms. The first central is carbon. We have another central carbon. We have another central oxygen. So in this case, how to find the geometry? And we have 3 centers with respect to the outer atoms. If we have this example, we look to find the geometry for each center atom as it was separated. For example, I said the geometry is with respect to this carbon is the following. The geometry for the second carbon is the following. The geometry with respect to the oxygen is the following. So this exercise is divided, this structure is divided into 3 structures, and I find the geometry in each structure with respect to its central atom. So now, for example, in this carbon, the form is AX4E0. So the figure of repulsion is tetrahedral, and the geometry is tetrahedral. The second carbon, the form is AX3E0. So the figure of repulsion with respect to this carbon is a trigonal planar, and the geometry is trigonal planar. I pass to this oxygen. This look as AX from this side, X from the second side. So this is AX2E2. AX2E2, the figure of repulsion is tetrahedral, and I have to erase 2 lone pairs. So the figure of repulsion is tetrahedral, and the geometry is bent. Okay? So figure of repulsion, tetrahedral, trigonal planar, tetrahedral. The geometry, tetrahedral, trigonal planar, bent. So as we divided this exercise to 3 different structures, we pass to an important characteristic of a molecule, which is the polarity. What is the meaning of polarity of a molecule? Consider, for example, ethanol. Ethanol is soluble in water. And ethanol, we know that ethanol is organic and water is solution. But ethanol is soluble in water. Consider oil, which is also organic compound, and put it with water. The oil is not miscible with water. So in the first case, we have one organic compound that is miscible with water. And in the second case, in the case of oil, we have organic compound which is not miscible, which is immiscible with water. So the question, why ethanol is miscible with water and oil is not? The answer is the polarity of ethanol is different from the polarity of the oil. For this reason, since the ethanol is polar, that means it has delta plus and delta minus sides. It will interact with delta plus and delta minus with water, and this interaction will make water close to ethanol, and in this case ethanol and water are miscible. In case of oil, the polarity is different. is not strong, and this is the reason that that oil is not miscible with water. So we have to know the polarity of a molecule in order to know its properties. A molecule is polar. It must have polar bonds. A molecule is composed of several bonds. If the molecule is polar, it should contain polar bonds. And a bond is polar when we have difference of electronegativity between the atoms of this bond. So the result, a bond is polar if it has a bond dipole which is different from 0. And to remember that the bond dipole mu is equal to the absolute value delta times d. If the bond dipole is not equal to 0, that means you have a value of delta. That means you have a difference of electronegativity. That means the bond is polar. So any molecule which is polar, necessarily it contains polar bonds. Second, a molecule is polar. That means its shape is non-symmetrical. What is the meaning? For example, if I have X2 linear, directly I can answer, since the structure is symmetrical, so this molecule is not polar. Trigonal planar, not polar. Tetrahedral is symmetrical. Trigonal pyramidal is symmetrical. Octahedral is symmetrical. Square planar is symmetrical. So any structure that is symmetrical means this bond is non-polar. A molecule is polar. First, it should contain polar bonds. Second, the shape is unsymmetrical. The shape should not be symmetrical. What are the unsymmetrical shapes? For example, band, V-shape, T-shape, seesaw, square pyramidal. These are unsymmetrical structures. Therefore, to know if a bond, to know if a molecule is polar, we have to know the geometry of the molecule. If this geometry is symmetrical, that means the molecule is non-polar, is not polar. Second, we have to know the geometry, we have to use VSEPR. Second, we have to know the polarity of each type of bond. So we have to calculate the bond dipole. And as by definition, the bond dipole is a vector parallel to the bond, and the intensity mu equal the charge absolute value of delta times dAB. Third, after we get the polarity of the bonds, we get all vectors. We try to add these vectors. If the sum of the vectors is equal to 0, that means the molecule is polar. And if the sum of the vectors, is equal to 0, that means you don't have polarity. The molecule is non-polar. And if the sum of the vectors is different from 0, that means the molecule is polar. So to know the polarity, we have to know VSEPR, we have to know the bond dipole of each bond, then we have to add all these dipoles. If the sum of these vectors is equal to 0, the molecule is non-polar. If the sum of the vectors is different from 0, the molecule is polar. Example, HCl molecule is polar or non-polar. We draw HCl, Cl is more electronegative than hydrogen. So we have one vector directed from the positive, which is H, to Cl. So we have one vector. And the sum of this vector is different from 0. So HCl is polar molecule. Consider CO2. We draw VSEPR. The geometry and the figure of repulsion is linear. We draw the bond dipole of all bonds involved. The first bond is CO. The second bond is CO. Which is more electronegative? The oxygen is more electronegative than carbon. So the bond dipole of the first bond is a vector parallel to the bond directed from the positive to the negative. And the second, the bond dipole is a vector directed from the positive to the negative. Now we have to add the bond dipole of all bonds. We have to add the vectors. Mu of the vectors is equal to 0 since we have two vectors in the opposite directions and the intensity of these two vectors are equal. So the sum of mu is equal to 0. That means we don't have dipole moment for the molecule. So the sum of mu is equal to 0. The bond is non-polar. We pass to H2O. Pay attention that we need to draw the geometry since we draw the vectors. Lewis is Lewis. If we write Lewis, that does not mean that we can write the polarity. From Lewis structure, we find the geometry. From the geometry, we find the polarity. So H2O, the geometry is bent. The first vector is parallel to the in this direction from negative. The second is directed from the positive to the negative. If you look to these vectors, we have two vectors in the same direction. So the sum of these vectors is different from 0. So we have a dipole moment. We have a net dipole moment, and the sum of the vectors is different from 0. So water is polar. NH3. We draw Lewis. Then we deduce the geometry. The geometry according to VSEPR is a pyramid, triangle, or trigonal pyramidal. Nitrogen is more electronegative than the hydrogen, so we have first vector from H to N parallel to the bond, the second from H to N parallel to the bond, the third from H to N parallel to the bond. Now add these vectors. Do the sum of the vectors. Is the sum of the vectors equal to 0 or different from 0? If you look to the sum of these vectors are in the same direction. So the sum is different from 0. And in this case, the bond is polar. The bond in NH3 is polar. So this molecule is polar. This molecule is polar. So the polarity, the importance of the polarity explains the solubility. Consider water, for example. We have delta minus and delta plus. If you put ethanol, the ethanol is a polar molecule. So the ethanol has delta plus and delta minus a charge. What would happen? Between the charges of ethanol, since the ethanol is polar, between these charges and the charges delta minus and delta plus of water, we will have interactions. So water will attract ethanol to itself. For this reason, the ethanol is soluble in water. Since water is polar molecule, so the other polar molecule dissolve in water. So as a rule, any molecule, any substance, any compound that is soluble in water, this compound is polar. Oil is non-polar, so it does not have delta plus and delta minus, or it does not have net dipole moment. It would not interact with delta plus and delta minus with water. For this reason, the oil is immiscible or not miscible with water. Some molecules have polar and non-polar parts, like soap. The soap from this side is polar, from the other side is non-polar. Example 3.6. Consider the following molecules. Explain the polarity. So first of all, pay attention. We have to write Lewis. We write Lewis. This is the best. Second, we deduce the geometry by Vesper. The geometry, the molecular form is AX2E. So the figure of repulsion is trigonal pyramidal, and the geometry is bent for AX2E. So we draw NO&Cl, which is more electronegative, N or oxygen, N or Cl. We follow the rule Falkland-Brice-Kapsch. So the oxygen is more electronegative than nitrogen. So we have a vector parallel to the bond from N to O. The Cl is more electronegative than nitrogen. We have another vector parallel to the bond directed from N to Cl. Now we have to look to the polarity. We add these two vectors. The sum of these two vectors is different from 0. That means NOCl is polar molecule. What is the meaning of polar molecule? Polar molecule means we have polar bonds, NO and NCl, and the shape is non-symmetrical, or the shape is asymmetrical. We pass to SO3. We draw Lewis. Then we have to deduce the geometry. The geometry is AX3E0. So the figure of repulsion is trigonal planar, and the geometry is also trigonal planar. Which is more electronegative, oxygen or sulfur? Falkland-Brice-Kapsch. So the oxygen is more electronegative than sulfur. We will have three vectors from S to O. Pay attention. This is the first. This is the second. This is the third. We have three vectors in a symmetrical shape. In the opposite direction, the sum of these vectors is equal to 0. So this molecule is non-polar.